Objective 9.1, to be able to solve for missing sides and/or angles of right triangles. For this triangle, we want to evaluate the three trigonometric functions of theta and also solve for the angle theta. Well, the three trigonometric functions that we're talking about are sine, cosine, and tangent. So we're going to have to remember those definitions. Sine is defined as the opposite over the hypotenuse. And if you look, we're standing here at theta. Our opposite side is 12. Our hypotenuse is here. So we're missing that hypotenuse. We would have to be able to calculate it. Well, if we know the two sides of a right triangle and we're looking for the hypotenuse, we need to use the Pythagorean theorem. So remember, the Pythagorean theorem says the leg squared plus the other leg squared equals the hypotenuse squared. So we know 16 squared is 256, and 12 squared is 144. Add those together, we have 400. To solve for the hypotenuse, since it's squared, to undo that, we have to take the square root. And so we know the square root of 400, that's a perfect square, is 20, and the square root of h squared is the absolute value of h. Now remember, the absolute value measures the distance from 0. And so we're going to have to go left and right that amount for that distance. If we go to the left, our hypotenuse would equal negative 20. If we go to the right, our hypotenuse is 20. Because we're talking about a length of the triangle, we cannot have a negative length, so we're going to have to use 20 as the hypotenuse. So we go back to our picture and fill in our hypotenuse. Now we can complete our three trig functions. The sine is defined as the opposite divided by the hypotenuse. So the sine of theta is equal to 12 over 20. Now we know that 12 and 20 have a common factor that we can divide out of 4, which would simplify to 3/5. The cosine is defined as the adjacent divided by the hypotenuse. Our adjacent side is 16. Our hypotenuse is 20. So the cosine of theta would be 16/20ths. 16 and 20 both are divisible by 4. So if we divide that out, it would be 4/5. The tangent is defined as the opposite divided by the adjacent. Our opposite side is 12, our adjacent side is 16. So the tangent of theta is equal to 12/16. 12 and 16 are both divisible by 4, so our final ratio would be 3/4. So we have our three ratios defined, sine, cosine, and tangent. Now we want to work on finding the angle measurement. Well, we were given the opposite and the adjacent side. That's your cosine. So let's use our cosine definition to help find that angle. Well, if the cosine of theta is equal to 4/5, we have to undo the cosine function. Well, when you're undoing, you're using the inverse operation. So we're going to do the inverse cosine of each side of our equation. These will undo each other, so theta is equal to the inverse cosine of 4/5. When we enter that into our calculator, make sure the calculator is in degree mode. You have theta equaling 36.9 degrees. You can check the angle measurement by putting it back into your ratio and do the cosine of 36.9 degrees, hit enter. Compare that to 4/5, and they should be equivalent.